These notes are to help you understand conic sections that are ellipses. Zoom in a tad bit. An ellipse has got some special parts, and they're not hard to understand. This is also a fairly easy topic, and it's going to help better when I give you examples. But an elliptical situation looks like this. There's going to be a major axis. There's going to be a minor axis. There's going to be a center, and there's a vertex here and a vertex here. The vertex, plural, is vertices. The vertex always are the endpoints of the major axis. So there's formulas. I'll show them to you, but I'll come back to it quickly. And you don't have to memorize the formulas. You're going to have x minus h squared. Let me zoom in a little bit better. The numerator has x minus h squared over a squared plus y minus k squared over b squared is equal to 1. It's similar to a circle, but there are some differences. If the x has the a underneath it, a is always going to be the larger of the two numbers. The ellipse looks like a football that's been lying down. The other form, x minus h squared over b squared plus y minus k squared over a squared equals 1. The only difference between these two formulas is the position of a and b. In this case, a is located second. It's under the y-axis. If it's under the y value, it looks like a football going up and down. So a is always related to the major axis. So major axis here, major axis here. B is always related to the minor axis. B is under the y, there's the minor axis. B is underneath the x, there's the minor axis. So coming back and defining some of these things, the center is always going to be the point HK. So the center of an ellipse is the same as the center of a circle, the same as the vertex of a parabola. The vertices are always going to be the endpoints of the major axis. And there are formulas for that. If I'm going to do the endpoints of the major axis, let's go back down these ones. So in this case, A is my distance from my center to a vertex. A is my distance from here to here. So I'm going to take H and add A, or I'm going to take H and subtract A. So I'm going to have H plus or minus A, K. If the ellipse goes in this direction, then I'm going to have to add A to the K value. So I'm going to have to go up A or down A. So the formula would be H, K plus or minus A. Once again, you do not have to memorize these formulas. I'll give them to you. They're not hard to memorize if you understand the concept. The focus points, and I don't have diagrams below, but you've got it on here. A focus point is along the major axis, and it's inside the ellipse, just like on a parabola. The focus point was on the inside of the parabola. And we don't have a p value, we're going to have a c value. C is going to equal, well, c squared is going to equal a squared minus b squared. C is the distance from the center out to a focus point. The plural of focus is foci. So the focus points, or the foci, are going to be inside the ellipse on the major axis. And to find the focus points, you need to know c squared is equal to a squared minus b squared. A is always larger and you have to move that distance along from the center. So if you're moving right and left, instead of adding A, you're going to add C. So one of the formulas would be H plus or minus CK. If you're moving up and down, you have to add C to K. So it's going to be H, K plus or minus C. Sometimes we refer to just what are called the endpoints. So the endpoints of the major axis are these vertices. The minor axis, they're endpoints, they don't have a special name. So the endpoints are just the points at the ends of the major and minor axis. This minor axis that we're talking about is this distance 2b. If b is the distance from the center out to an endpoint, this length 2b is the length of the minor axis. The length of the major axis is 2a. So if this diagram shows it again, 2a is the major, 2b is the minor. 2a vertical, up and down, major, 2b minor. The only other thing that occurs is this idea of eccentricity. Eccentricity is going to be a ratio of c divided by a. And if you think about it a little bit, if c is the distance, let's go to this problem. C is this distance from the center to the focus point, and A is the distance from the center out to the end. If C is close to A, then this ratio gets really close to 1. It can never be greater than 1 because you're never going to have C larger than A. If C is a lot closer to the origin, so it's very small compared to A, you're going to have a value closer to 0. So what happens is if the eccentricity, the ratio of C over A, the closer it is to 0, the closer the ellipse looks to be a circle. The closer the value is to 1, the more elongated the ellipse is. So let me go through a couple examples. So I've got my first example is x minus 2 squared over 25 plus y plus 3 squared over 9 equals 1. Right away I want to see which value is larger, the 25 or the 9. The 25 is larger, so I know since the 25 is under the x, it's going to be a flatter football. It'll be lined on the ground. So I'm first going to start out with a center. My center is the point 2, negative 3. So I go over 2, down 3. And I'm not using formulas so much. I'm going to go ahead and find my vertices. Remember, my vertices are along the major axis. My major axis is along the x. So it means I'm going to go the square root of 25. So I want to go 25 to the right, or excuse me, square root of 25, 5 to the right. And that is the point 7, negative 3. And I'm going to go 5 to the left from the center. So it's going to be this point here, negative 3, negative 3. Then I can go from the y value, I have to go up and down the square root of 9, which is up and down 3. So I'm going to go up 3, and I'm going to go down 3. I don't need to list these points. They don't have any special meaning. I just put them there to help me draw it. Now I'm going to try and make a smooth curve. And there's my ellipse. To mark my focus points on here, I need to find the distance C that goes from here to here and from here to here. It's along the major axis. So C squared equals A squared minus B squared. 25 minus 9 is 16. The square root of 16 is 4. So I know I have to go 4 to the right. It's right here. And 4 to the left, which is right there. So my focus points are going to be 6, negative 3, and negative 2, negative 3. The eccentricity is C over A, so C is 4, A is 5. So this number is closer to 1. That means the ellipse is more elongated. If it was closer to 0, it'd be more like a circle. My next example, let's compare them really quickly. A is always the larger the number. So A squared was 25. A squared is going to be 36. Here, the larger number was under the X, so it looked like a football line down. Here the larger number's under the Y, so it's going to look like a football going up and down. So I first go ahead and find my center. My center is going to be 0, 1. So I'm going to make a point 0, 1. My major axis is under the Y, so I have to go up 6 and down 6. So these are my vertices. So it's going to be 0, 7, and 0, negative 5. I'm going to, under the X is a 4, so I need to go to the right 2 and to the left 2. Sketch an ellipse close as I can. Now I want to identify my foci. My focus points are along this major axis. So this major axis is going up and down this way. I know that C squared equals the largest minus the smallest. Square root of 36 is 32. So I know C is going to equal to the square root of 32, which breaks down into 4 square roots of 2. And I don't need to know exactly where that is. I know the distance, square root of 32, since the square root of 36 is 6, it's smaller than 6. The square root of 25 is 5, it's larger than 5. It's going to be between 5 and 6 away from here. So if I go up 1, 2, 3, 4, 5, somewhere between 5 and 6, that's all I need to go. 1, 2, 3, 4, 5, somewhere between 5 and 6. So those focus points, really hard to see, but when I identify them, I know that they're going to have to be along the major axis, so the X value is 0. And I started at 1 and I went up 4 square roots of 2. Started at 0 and then 1 minus 4 square roots of 2. So there are my focus points. My eccentricity is going to be C, which is equal to 4 square roots of 2 over A. A is going to be the square root of 36, which is 6, which breaks down to 2 square roots of 2 over 3. The last thing we're going to need to do with this is go ahead and complete the square. When I complete the square, it's going to be very much like a circle, but there's going to be an extra step. So I'm first going to go ahead and isolate. So I have 25x squared minus 200x together. I'm going to put the y's together. So I have plus 9y squared plus 54y. And I'm going to put this 256, move it to the other side, so it becomes negative 256. What's different here is I'm actually going to have to factor. I don't have just an x squared. I have a 25x squared. So when I factor this first group, I have to factor out the greatest common factor, which is 25. I don't want to factor out the x. I want that staying there so I can do a factoring. So I have 25 x squared minus 8x. Here, I have to factor just the 9 from both of these y terms. So I'm going to have plus 9 y squared plus 6y equals negative 256. Now I want to complete the square, but this is the hardest step of all of it. When I take half of negative 8, it's negative 4. When I square it, I get 16. So I'm going to add 16 here, but I have to multiply it by 25. So when I write it down, I'm going to have x squared minus 8x plus 16. When I put it on this other side, I'm going to leave a little bit of space. I added 16 multiplied by 25, so I have to make sure I do this on that side. Half of 6 is 3. When I square 3, I get 9. So I added 9 here, but I multiplied it by 9. So I'm going to have to add 9 times 9 here. Okay, then I can factor this first group. So I have 25 x minus 4 squared plus 9 y plus 3 squared. And when I add all of this together, I get 225. I need this to equal 1. To get this to equal 1, I have to divide everything by 225. When I reduce this fraction, 25 over 225, I get 1 over 9. So I'm going to get x minus 4 squared over 9. When I reduce this fraction, 9 over 225, I get 1 over 25. So I get y plus 3 squared over 25. And this side is equal to 1. Same as a circle, with just one extra step, and you have to be a little bit more careful with the math.